This experiment is a very common experiment in chemistry, and if you see the students all over the world, any country, if he is a chemistry student, he must have done this. So it is very common experiment in chemistry. Today I have made it very simple for you. When you will understand this, later you can do the difficult, the complicated type of titration. But today, just because you are doing it first time, so it is simple for you. Can you see? Otherwise, there is place. There is place. You can stay here because it's important for you. I will show you today how to do this experiment, stepwise, everything. Next time, when you will come, you will not stand here. You will go directly to there on your seats and you will start experiment without asking any question. Did you understand? Today you are doing nothing. Just look me. If you want to make video, picture, audio, whatever, if you want to make, you are always welcome. But next time you do it by yourself, directly, without any questions. Did you understand?
Yes.
This experiment is called standardization of a base. Standardization. You know, yes, to see what is the concentration. Concentration means tarkis. We have two solutions. One is a base, sodium hydroxide, qaida, and one is an acid, acetic acid, hummus. We have two solutions. We know the concentration of this one. Concentration means tarkis. We know the concentration of this one, and we don't know the concentration of this one. We will do the experiment to find the concentration of this one. Okay, that is the experiment. Did you understand? If there are two things, you must know one of them. Only then you are able to find the other. For example, if I ask you what is the length of this table, you must have something standard, mayar, like meter. So you can measure and you can tell this is 2.5 meter, like that. Okay? We know the concentration of this one. This is a table which is given on the page 64 on the book. Next time when you will come, you will fill this table as I am doing it today. So today you will not write anything. You will just look around on the page 64.
Next time?
Next time.
I will.
Yes, next time you will do it. Next time. The same way as I am doing today. This is the table. It is similar. To your page 64. And I will show you how to fill this one. Okay? As I said, this is the acetic acid, hummus, and its concentration 0.680. Concentration is called molarity. 0.680. This is known, maruf. The other one is unknown, majhul. When you will do this experiment next time, two students will do together. For example, here, look at here. There, 1 and 2 they will do together. 3 and 4 like that. two students will do together. Because you are doing it first time, so you can help each other. When the two students are there, each of the student will do his own work. I will show you, I will tell you what work one student is doing and what the work other students is doing. You have here a small beaker, a funnel, a conical flask, a volumetric pipette and a burette. All these things, you can see that all the things are very neat and clean. When you finish your experiment, the things should be like that. It should be like that. It's all neat and clean. Who make it neat and clean? The previous group. And you will make it, when you finish the experiment, you will make it like that for the coming group. I will ask one of the students to bring the small beaker, this one. So, one student will bring the beaker, small beaker, and I will give him, in the beaker, I will give him sodium hydroxide. I will give him some amount. You will see that this amount is too much. When I will finish the experiment, you will see that more than half will be not used. So this is sodium hydroxide, put it on one side. Okay? This student who took the sodium hydroxide, he will fill the burette. I will tell you how to fill the burette, I will tell you. The other student will take these two things. These two things. Second student, did you understand what I am saying?
Yes.
And he will take acetic acid, this acetic acid. I have placed the acetic acid in 4 places. You can see that one. 1, 2, look there, 3 and 4. I have put in 4 places. The other student will take these 2 things. Not only one, not one, 2 things. Okay? Before we start the experiment, this flask, this is already washed with the tap water.
Yep.
Already washed with that one. Before I start, I will wash it with my makatar. And I can throw it there, or I can take a other beaker. Not this beaker. I can take another beaker, or I can throw it there, as you like. I will also wash this one with the distilled water. I will wash it with the distilled water. Some distilled water, that's enough. That's enough. When I wash with the distilled water, there is still some drops of water.
Yeah.
And I want to remove them. So, I will take some part of this one. This is one student who will be doing. The other student will do the other part. He will not watch him what he is doing. He will not stand waiting that what he is doing. No, he will do his job. I will tell you how he is going to do his job. So, I take this one and I wash it, or you can say I rinse it with this. Right? Now this is ready to be used. Now I will take this one up to the mark. It is not easy. It will take maybe 5 times, 6 times, many times. It needs some experience. This is acetic acid. This is not dangerous. This is khal. You take in the food.
Yeah.
Right?
Yes.
So if there is water, it is not dangerous. If there is glucose solution, not dangerous. If there is a Pepsi, not dangerous. You drink the Pepsi.
Yes.
So that's why we are doing it with the mouth. So if you drink little bit, nothing to worry. Okay? Nothing to worry. This is khal. Okay. But if something is dangerous, then we will use the pipette filler. We will use it in some other experiment. You need to know to learn both of the ways. So this is the easy way, that's why I'm using this, right? And I will take this one. I will take it above the mark. Did you see?
Yeah.
I will take above the mark and I will release the air from my finger. I will release the air. When I will release, it will go down like this. And it may go down like that.
Down.
So what to do?
Again.
Take it again. So maybe you have to do it many times. Okay? Did you understand?
Yes.
So nothing to worry. Don't confuse. Nothing to worry. If you take 5 times, 6 times, because you are doing it first time.
Mm.
So no problem. There was 1 drop difference. We don't want a difference of even 1 drop, because it has to be very accurate. Like that. And now you put it here. Make sure you have the flask with you. I know some students are careless. They will hold it here and they will come to your seat. From there they will come here and they will look, where is my flask? Where is my flask? No, it's not there. The flask should be with you, washed flask. And you will not blow it. Don't blow it. When everything is gone, touch it twice. 1, 1, 2. On the empty side. Not here in the solution, on the empty side. So there is a drop there. Don't worry about the drop. This is exactly 10 milli. This has been designed like that 1 drop will remain there. So nothing to worry. We will never blow it. You are doing the experiment first time. I will not care about the result. If the result is wrong, I will excuse. But if the technique is wrong, I will cross. So you are learning the technique. If you are taking it, your flask should be with you. Everything, look at carefully, look at me, how I am doing, and you do the same way. And if your answer at the end is wrong, don't worry. I will give you full grade. Okay? But the technique should be correct. I told you there is no final exam. There is continuous assessment. Continuous assessment. That's what I am looking for. Okay? You are learning here. So you learn. Don't worry about the result. Okay?
Okay.
Now, one student will do this thing. What the other student will do, the other student will not wait for him. The first student, maybe he will take 5 or 10 minutes.
Yeah.
In those 10 minutes, the other student will fill this one. How to fill this one?
Took the pen out.
You put a beaker, not this beaker, another beaker, and wash it with water and move this one. You see this one?
Yeah.
You move it and wash it with water. Don't put too much water. This is more than enough. Don't put too much. This is enough. And now you open it. So all the water will go down. Now it is washed with the distilled water. Right? But still there are drops of water. We want to remove those drops. So I will wash the burette with this solution. Okay? Like I washed the pipette with this solution. So I will wash this one. Alright. Now I will take the funnel, put over here, close it, take this one and put some quantity over here. Some quantity, not too much.
Okay.
small quantity, even smaller than this one. And I will take this one and I will move it over here. Not here. And then I will open it from here.
This is for clean.
This is for cleaning, final cleaning. This is called rinsing. The final cleaning is called rinsing. So you see that. Now it is all, if there is any drop, what is that? Sodium hydroxide, this one, right? The solution. So now if there is any drop, we should not worry, it is the sodium hydroxide. Okay?
Okay.
Now, I close this one, put it over here, and I will put this one into it. You can see that there is a liquid. Liquid. Actually, why it is there? Because there is air. And sometimes it bump out. So what is the method? The method is move it above. Little above with your finger. Did you understand?
Yeah.
Move it above, and now you will see there will be no liquid staying there. Because now the air can go from that place. Fill it to any mark. Above the zero or below the zero. It makes no difference. Keep it on one side. This is sodium hydroxide. It would be above the zero or below the zero, no problem. This is over here, and I will open it first, move it down, and bring it down any point. Any point. Here, 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 any point. Right? And then you will record this one. There is a graduation number. There is number. I can see it from the number. If you look the burette, this is the burette, starting from 0, 1, 2, 3, 4, up to 50.
Yeah.
The burette is up to 50.
Yes.
If you look any two number, for example, if you look between 1 and 2, there are 10 lines.
Yeah.
Between 1 milli and 2 milli, there are 10 lines. Each line is equal to 0.1. 0.1. Very good. Each is equal to 0.1. Because this is 1, so that will be 0.1. In the middle, there is a big line.
0.5.
Yeah.
0.5.
1.5.
If it is coming in the middle one, so then it is 1.5. Right?
Yeah.
So
Yes.
now I will see that what is the volume now. I will bring it down up to my level, eye level. I will not see it like that, or I will not see it like that. It should be exactly at my level. Then I can take the correct reading. If I read it from here, if I look into this, I can look it. But if I want to take more accurate,
Close one eye.
then I will put a paper behind it. Okay? When I put, then the light will not be all passing through. So now, if I do it like that, if I do it like this, that will be much better as compared to like that. If I see it, this one, I have little problem in that. But when I put it like that, I can see the meniscus very carefully. And now I see it is 1.6. It is 1.6. This is the 0.5 and down is the 6. So it is meniscus is like that. Alright? This big line and one below. So this is equal to 1.6. Right?
Right.
This is my initial reading, where I start. As I said, you can start from any point. It makes no difference. If your solution is not enough, no need to fill up to here. You can start from here even. Okay? So 1.6, initial burette reading. So initial burette reading is 1.6. This work will be done by the second student. He has made the burette ready. He washed the burette with the distilled water, the second student. He washed it with the sodium hydroxide, and then he read it over here exactly after as I did. Open it fast, so everything will go fast down, and then close it and then take the reading. This is the second student has done. The first student has done this one, the second student has done this one. Yes.
Then I take it again.
تصوير باين عليه؟ باين هذا؟
When another student come.
No, this is the, there are two students.
Yeah.
One is doing this one, and the other is doing this one. Okay? Now everything is ready to do the titration. This is a beaker. Keep it on one side. What is in the beaker? Sodium hydroxide. So we may use it again. So keep it in one side. Don't put water. Don't put anything in that. Don't put any washing in that. No waste there. Did you understand, boys?
Yeah.
Okay, now what I will do, I will put this sodium hydroxide into it. Come, how many milli I should put in that?
1.6.
No, 1.6 is this one. From here, how much I should put?
Maybe
0.4.
1.1.
0.4.
0.4. Anybody else?
No.
How much I should put? 5, 10 or what?
To be full. To be full.
كم 1.6
7.
2.6
So if I know 2.6, if I know 5, if I know it is 5, if I know it is 10, then what is the use to do this one? If I know already how much I put, then what is the use to do this one? There should be someone who told me stop, don't put more. Who will tell me this?
Your partner.
Huh?
Class?
No, the doctor.
Your class?
Me.
When I will put this one, who will tell me, okay, don't put anything more?
The
Here
baker
is, this will tell me, indicator, kashif. This will tell me don't put anything more. Okay? And I will put this indicator 1, 2, 3, 4 drops, up to 4 drops. 3, 4, 2, 3, 4, like that. And this indicator, this is phenolphthalein.
What is it? What?
This is phenolphthalein. Phenolphthalein.
This
It's
is work or student together or
yes, together.
Okay.
So this phenolphthalein, there are so many indicators, so many. Dozens and dozens of indicators are there. Remember this name. It is one of the most common. Every student knows its name, every student. So you must know it. Every science student know its name. This is phenolphthalein. Very big name. Phenolphthalein. So this indicator will tell us stop. Right? Now listen to me. I have here acetic acid. How much acid I took? 10 milli. 10 milli. So I will write volume of the acetic acid 10 milli. I know the concentration of the molarity of the acetic acid, right? It's written there. I know the molarity. Now I will do the titration. I have a very simple formula. This is acid equal to base. Here is molarity of the acid times volume of the acid is equal to molarity of the base times volume of the base. If you multiply molarity and volume, two things. If you multiply two things, this is called mole. Molarity times volume is called mole. This mole will be equal to this mole. When there is an end point, the color change, I will show you. This will be equal to this one. So the moles will be equal. When the moles are equal, only then there is a color change. How many things are here?
4.
4 things. If you know 3 of them, you can find the 4th. Right? So look, molarity of the acid is known. It's written there, 0.68. Volume is known, it is 10. Molarity of the base we want to find out. volume of the base, I will get it when I complete the experiment. And then I can find out this one. Did you understand?
Can you repeat?
We have 4 things.
حط التوية.
Out of 4, we will be
مو
doing
توقفه
3.
كامل.
Right now, I know 2 things.
لا 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 مو المربع.
Polarity of the
الثاني اللي في
acid,
النص
I know it.
اضغط عليه.
I will know after the experiment. So I know 3 things. The 4th, I make it as a subject, one side, I can find out that. Okay, now, this is the flask, and when I will add sodium hydroxide into this one, I will shake it with 3 fingers. Not like that, not like that. With the 3 fingers, and I will swirl it, not shaking. I will swirl it. Swirl means move like that. Yes.
Can I put my phone together like this?
No, no, never, never, never. So I will swirl it. I will swirl it. And similarly, I will hold this control with 3 fingers, with the other 3 fingers, and I can put this into there, and you can see that when I put that, look over here, there is a pink color coming.
Yes.
Do you see the pink color?
Yes.
But this pink color, it disappears. It comes and it will disappear. Right? And why? Because the molarity is not equal. When they become equal, then the pink color will stay there. Okay?
Okay.
When I will do the experiment, yes.
When the water come, I shake it and it will
Yeah, I will show you. I will show you. I will show you. I will show you. Now, so I will control it in such a way that I will not put too much. I will put, for example, drop wise. Do you see that? I am putting drop wise. So I am shaking it and controlling over here and shaking here. You will see that when the pink color, do you see the pink color?
Yes.
When the pink color stay long, if it stay long, it means that the end point is near. Now the end point is not near because the pink color comes and disappears. When the pink color, it stays little long for more time, then the end point will be near. And you can see that I am adding a dropwise and I am shaking it. And with my second hand, with this hand, I am controlling it so to make sure that I should not add anything more. And you can see that, look over here, see the pink color. You see this one?
Yes.
Up till now it is there. What does it mean?
It's not
No, it's not
Yes.
equal.
Volume near.
Near. It means that the end point is near because it is up till now it is there. So when the pink color is staying there, so make sure that now you are very careful. Okay? So when you are doing this experiment, make sure that you are not in hurry. Nothing to hurry. So do it slowly. When I am putting the drop, the end point is near because it stays long. Maybe in few drops, I will get the permanent pink color. So, because I have more experience, I'm doing, since I can do it, so I can do it even fast. You don't do it fast. Because you are doing it first time and you must get it with one drop. The pink color should come with one drop. So let's see. So, you put a drop and
It will take a long time.
doesn't make any difference. You have plenty of time. This is the accuracy. In some experiments, we need it is very near. Maybe I need only 1 or 2 drops, and I have to put it very carefully that 1 drop should come. I have to do it very carefully. So, because if you are in hurry, you can never put 1 drop.
What happens if we drop it one time?
Then the answer will be wrong. Then the answer will be wrong. No use to do the experiment. We want to know standardize. Standard mean mayar. So we want to make something mayar, standard. So this is end point, but
Oh.
this is end point. You see it came with 1 drop. Did you see that one?
Yeah, 4 drops.
And
That's the clever.
huh?
All it's pink.
All is pink. Now it is not going.
Wait a minute.
And if you find it is very light, if you find this is the best color, this is the best color, but if you find it is very, very light, you can put 1 drop more. Okay? So right? And it came with 1 drop. So if you get with 1 drop like that, it means that you have done it excellent.
When I put another drop.
And now it will remain like that. I will show you. I will show you. Let me complete the experiment. I will show you that. And let's suppose now the reading is now 13.3. When you read it, put the paper and look it carefully. This is 13.3. How much is the difference?
11.3.
7? 11.7. This is the volume of the sodium hydroxide I used. This is the volume of the sodium hydroxide I used, right?
The volume in millimeter.
Milliliter. Okay, boys. If you put more, for example, look, if you put more, it will remain same, but our experiment will be wrong, because if I take now, that is the wrong reading. That is the wrong one. It should change with 1 drop. To make sure this one, I will repeat the experiment, and there are many new things which you will learn now. When I do second time, can you please watch this one? Only with the tap water. So I will do this experiment, and in the second time when I am doing, you will learn new things. I want to tell you that when you repeat the experiment, of course you have to, when you repeat the experiment, then let the other student you should change your work. Now the second student should come here to take the acetic acid. Okay? So he should also get an experience. Did you understand what I said?
Yes.
Okay, now look, you tell me what to do. This is the now washed with the tap water.
Yeah.
What I do?
Water, wash.
Wash it with the.
Wash first.
Do I need to wash with this one? Do I need to wash this one?
No.
No, because already there is acid. Already washed with water, already washed with the acid. So when you take it, some students they feel easy with this finger, and some students they feel easy with this finger. It is up to you, whatever you like, because some students are doing like this. Okay?
Okay.
So and when you do it, it will take certain time, and you should be doing it carefully. Do you see it is going down?
Yeah.
Like that, and like this. Because I have experience, so I did it in one time. If you do it in many times, nothing to worry, nothing to worry. Don't blow it, and let it go by itself, and when it is empty, 1, 2. And there will be a drop. Don't worry about the drop. What to do next? Indicator. How much? 1,
3 or
2,
4?
3 or 4. Okay. This is ready. What to do now? Take the initial reading.
Yeah.
You can start from any place. You can start from any place. Look,
No one.
yeah, I'm changing it. Just to show you, intentionally I'm changing it, that you can start from any point. Alright? Now, I take this one and 14.1. The reading is 14.1. This is the initial reading. Is that right?
Yes.
Now I ask some questions from you. This is my initial reading. Let's suppose, listen carefully, now you have to answer a question. Let's suppose that I am doing it, the first reading very accurately. Let's suppose this is the correct answer. 11.7 is the correct answer, which may not be correct. But suppose this is the correct answer, it means that I should get the difference, again I should get the difference 11.7. Right?
Yes.
If it is 11.7, what will be the volume here?
Change.
5.8.
How much?
It's
25.8.
25.8. It should come as 25 and 25.8. It should come here. This one plus 11.7, 25.8. It should come like that. Yes.
Why you said the 25.8?
Because suppose this calculation.
What?
Why I did this calculation? Why I want to know 25.8? What's the reason?
See difference between first time and second time.
Do it fast.
I am sure about the first
No.
one.
You
Do
know,
it
I
fast.
can, if I do it without this one, without this, if I do it everything without, I can get the second. So why I did this one?
Do it fast.
because you know how accuracy or not.
Do it fast.
To do it fast, yes.
Yes.
Correct. To do it fast. If I don't do this one, this calculation, I start it like before, add drop wise in the same way, it will take a lot of time.
Yeah.
But now I know that it is 25.8. So what I will do, I will take directly 24. Directly. Okay? No need to put drop wise, because I have an idea. Why not exact 25.8? Why not exact 25.8 directly? Because maybe this is wrong. Maybe
Yeah.
my first reading is wrong. So up to 24, I will put directly. So, is it the end point?
You need to check.
No.
Okay. Now, what I will do?
You will
Now
drop
drop
the
wise.
twice.
Yeah.
So, careful and add. Like this, and I will move it like that. One drop at a time. Do you see that?
Yes.
One drop at a time. And when the end point is near, how I know the end point is near?
The color long. Stay long.
Stay
Stay
long,
longer.
change in one drop.
The color it stays long. The color it stays long. So now I will be more careful. Right? This is how you will do, because this is the experiment. Not only this time you are doing. When you are studying research work, maybe the hundreds time you will do such type of experiment. Not the same. So many titrations are there. This is the simplest one I made. Okay? So now can you guess how many drops I need?
3 to 2.
Maybe 5.
4.
One more time.
One more.
I think.
next one.
No. One more time.
That's the best endpoint.
Yeah.
But I put one more. That's the endpoint. I know that the color is changed, and
Yeah.
this is permanent. Everybody can
This
see.
is the best.
This is the best color. This is the best color.
Okay.
Okay,
If,
but
I left it like that when I make the experiment. It's good.
yeah, it's very good. It's very good. It's very good because when there is a color change, when there is a color change, that's the end point. Okay, and now I will take the reading like 25.8.
Same.
Same. 25.8. Okay, boys. Now the reading is 25.8. But you are doing it first time. Okay? Let's suppose you get 25.9. Let's suppose you get 25.9. No, it's not wrong. So what will be this volume?
11.8.
11.8. This is 11.7. Now this is 11.8. If it is coming 11.9 or 12, 0.3 for you, I give you this discount. 0.3 plus and minus. Do you understand plus and minus?
Yes.
0.3 plus or minus of the initial. If you get like that, that is the correct. I will accept it. And if it is more than 0.3, what to do?
Again.
Do it again. No problem. Do it again. You have plenty of time. If it is more than 0.3, do it again. I will show you how we will start with the calculation. I will not do the third time. Did you understand?
Yes.
Please watch this one. Please watch this one. And what is over here? What is over here?
Hydroxide.
Sodium hydroxide.
Hydroxide.
You take the sodium hydroxide back. Alright? Return it back. And as I told you, whatever the quantity I am giving to you, that quantity is, you will not use even half. And you see that one. Alright? That quantity is more than enough. This sodium hydroxide, which is here, don't put it back over this. Because, why you will not put it back? No, maybe not very clean. Maybe some mistake has been done.
Yeah.
And I don't want to make it wrong for the other groups. What you will do, you will collect over here
And
and then put here in the big beak. I will make it neat and clean, this one. I will make it neat and clean and then we can use it later. Did you understand?
Yes.
This flask now is washed with the tap water. My experiment is finished. Should I wash it with the...
No. Another student, he will.
Another student will come and he will do... Look, here is the sodium hydroxide which is come over here and put it back. Yes.
Should we wash it with sabun?
No need, because it is not precipitate. It will go with tap water. It will go with tap water. Now, listen. This you will wash with the tap water. But look at the burette. It is empty. But there are drops of sodium hydroxide. Sodium hydroxide is a base. It will react with the air. What is acid in the air?
Oxygen.
No, oxygen is not acid.
Hydrogen.
What?
Oh, it's hydrogen.
Hydrogen.
Which gas is acidic? Oxygen is neutral.
CO2.
Hydrogen.
Carbon dioxide. Carbon dioxide. Carbon is non-metal. Non-metal oxides are acid. Metal oxides are base. So there is carbon dioxide. It will react with this one, and this pipette at the tip, it will be blocked because of the solid. Sodium carbonate is solid. Did you understand? Yes. How can release this? Put it, this one, the washing one over here, and you wash little bit with the distilled water. Take this one and put some distilled water over there like this. This much amount. It will remove all the sodium hydroxide and your burette will not be closed. Otherwise, it will react with the air, so carbon dioxide, and form sodium carbonate, which is solid. And the next student, when he will come, he will find difficulty to do the experiment. Yes.
Dictor, next when we do the experiment.
Do the calculations. Yes.
Here I put anything I don't need. Or
No,
just
just
the-
sodium hydroxide, not anything. Not this water, not this vacuum. Only sodium hydroxide. Use sodium hydroxide. Yes.
How much amount of thinking did you put?
How much amount of?
10.
10
Sodium
milli,
hydroxide.
10 milli, 10 milli. Yeah. Okay, boys, listen. Look at this table. Look at this table, the first line, and tell me how many information I have there.
3.
What are those? What are those? I have the molarity of the acid,
Volume of
volume of acid, then
volume of
base. Volume of the base. Don't take this one because the difference is this. No need for the initial and the final. Initial and the final could be changed.
Yeah.
This is the important. This is the important thing. So I have 3 information. Now, what is the molarity of the acid? 0.680. Volume is how much?
10.
10. Volume of the base is how much?
11.7.
11. Anybody has the calculator? Do the calculation, please. This table is exactly what is in the book.
Yeah.
So next time when you come,
0.58.
tell me 3 digits.
0.5811.
1. 0.581. Okay. Now I will do this one. Now I will do this one. 0.680 into 10 over
11.8.
Please check.
0.57.
576. Now add both of them
The difference
and divide by 2.
5.
اجمعهم واقسم على 2.
0.78.
No.
0.578.
578.
What we should do?
0.5. This is the average. This is the
yeah.
average. Listen, boys. If, for example, these two are not close, more than what?
0.3.
If they are, you will do the whole thing one time more. So third time when you do it over here, if your reading is, this is similar to this one, third is similar to first, cancel this. And if the third is similar to 2, cancel that one. The 2 which are very close, select them and take the average. Calculate them separately, and then you take the average. Did you understand?
Yes.
It's a very interesting experiment. When you will be doing it with your hand, definitely you will like this one because you are not going to do it only for today. In future, many of you will be doing the research work, and this is the essential part of the research work. And there are so many difficult titrations. This is a very simple one I have made for you so you can understand. Yes.
Doctor, how you